or Arduino that I had used for my Lost in Space robot. And what I'm looking to help out with is to actually show the assembly of this, and really this is all the components needed. Once again, you can go to the Arduino website and look at the standalone or breadboard Arduino. This has been the same instruction since about 2008, so there hasn't been a lot of change to this. This chipset is stable and works very well for limited applications that we would use it for. The things that I'm not going to do with this is adding these additional boards that are here and also here, because we're going to do the programming and the breakouts from within our development platform we already have. So to get started with this, I wanted to show you some components that I'm going to use to put this together. So of course the ever important development platform here, the Arduino Uno. So this was sourced from Amazon, and you can definitely find them there at a lower cost than what I bought it for earlier this year. Something else that's kind of cool is this Sidekick Kit, and this had a bunch of different components that were useful: sensors, switches, all sorts of servos, and different jumper cables. I'm actually using it to transport a few things. So a couple other things that will be required are some, I like red and black for positive and negative, my switches, some resistors, and in this case these are 10K, 10,000 ohm resistors. And then we'll also need two 20s, which I have in another box over here. And I have some miscellaneous other connectors and some loose LEDs in here as well. Now, like I said, I was just using this to transport some stuff around. Some other things that are going to be required for this are crystal timers. So this acts as the kind of like the clock of the operation here. Keeps everything in sync. Capacitors, which this right here is a multi-piece set, and this can also be sourced from Amazon. And what you can see in here is there's any number of capacitors here that you could possibly really want. There's just 2 or 3 that I'm going to use out of this package, but I brought the whole thing with me just to keep everything together. Another important component are these guys right here. These are voltage regulators, and what this allows you to do is to feed in a 9-volt source or a 12-volt source, and it will automatically step it down to 5 to power your microcontroller. So this is an important component, and actually you could put everything together, and if you just supplied 5 volts, you wouldn't need these. But since we're going to have variable supply, or we may pick a higher voltage than 5 to power everything we need to power, this is another good idea. And of course our breadboard. This is the development platform where I can plug in my Arduino here and put my jumpers over, and then some LEDs that I'll probably use to test in addition to some of the other things that I'm going to be doing with this. 9-volt battery is good to have around. And then also my microcontrollers. So I'll only be using one. I brought the whole package with me for this demonstration. And another super handy thing, that if you're new to electronics and you don't already have one of these, a multimeter is super important. For me personally, it's great to have around because I'm not very good at telling the colors on the resistors, so you can actually test the resistance of your resistors if you're not sure what they are rated at. You can see here that I have all my components picked out and laid out to be put on the breadboard. First thing that's going to get added is the power regulation, and really the important component here is to understand which poles these need to go in. So there's an order that this goes to, and there's a picture of it up right now that shows how this fits into the breadboard. It's very important that the input and outputs are set up correctly. Next, we're going to put our power regulator in. See, the important component here is making sure that these are going in the right order. So you can see here that I've got power coming in, I have my ground, and then this last is the output. So my power is coming in here through the regulator, and then I have a hot wire right here that's going to come down, and it's going to end up connecting to the microcontroller, and then the ground comes all the way through. A couple other components we're going to put in here are capacitors. Another thing that's important to note about these capacitors, this is always the negative side, and they're denoted on these types of electrolytic capacitors. So you have to make sure that you're always paying attention to that, and when I plug this guy in here, I'm going to trim this down a little bit, just because I don't want it to be too high. But like in most applications like this, longer end is positive, shorter end is negative. So we're going to put one of these here. Making sure we make contact all the way through. And the same thing. On this side. And in this case, we're going positive and ground. So there's our power supply. This part is optional, but this is a good idea to allow you to do troubleshooting of this configuration. By putting in an LED here, we'll be able to see that our board is getting power. So we're going to add this guy here. Note power positive and negative. And what's good about this is we'll be able to make sure that we're completing a circuit and we're not shorting anything out. So here we have finished power. So we should have a circuit going all the way through. Now we'll be able to start adding components. Now it's time to add our microcontroller. So this is our AT-Mega right here. The brains of the operation. The important thing to note about this is the notch that's here. This denotes that this is the top of the chip. So when we're numbering pins, we start at 1 and work our way all the way around. Right now is displaying the map, the pin map for the ATmega to tell you what each of these pins means. And what we're going to be doing here is connecting the proper pins to the proper power and resistors. So we're going to add this guy. And you want to make sure that you give yourself enough room on your board. Make sure my pins are fairly straight here. So there he is, right there in the middle. We have a few of these pins that we need to connect to ground, and also analog reference and digital supply voltage. So pin 7 is the first one that we're going to be doing this with. And what's important to note here is we're going to be counting pins down. So starting as 1 here, 1, 2, 3, 4, 5, 6, 7. So that's on line 21. We could have done the math there. That's going to get positive voltage. And then we have negative voltage going to pin 8, or ground. So we'll make another one of these guys. So there's that. Pin number 22 also gets a ground. So the important thing to note about this, pin number 22 is starting at 15 down here. So if we're going to count this out, 15, 16, 17, 18, 19, 20, 21, 22, directly across from here. So line 21, but remember we're broken in the middle, so there's no circuit going across here. We're only going this way, we're going this way. Pin number 21, which will be the next one down, is an analog reference pin. And then pin 20 is supply voltage for ADC converter. So now we're adding our clock between pins 9 and 10. And this is also where we add resistors. So pins 9 and 10 are directly below 7 and 8. So we're going to take 9 and 10. Connect our clock, and these are connected with our resistors. Doesn't matter what the voltage is, these are actually going to get connected to our negative. Next we're going to add a reset switch. So we're going to stick this reset switch right above, and at this point we're ready for pin 13, which is one of our first output pins. So output on here means that we're telling a pin to turn either on or off. In this case, pin 13 is always on. So on a standard blink type of program, we would cause this guy to blink. And what we're ready to do at this juncture is to program this chip. And what I'll do next is we'll remove this and put it into the development platform to program through the IDE, which is basically the programming interface.